Hey, what's up, everybody? I'm Divya. Welcome to Visual Vibes. In this Python course, I'm gonna teach you everything that you need to learn to start coding with Python. This course doesn't cost you anything, it's totally free for you. But if you would like to help me out, then you can increase its reach by hitting a like button, leave a random comment down below, share, and subscribe to my channel for more videos. Thanks in advance, and I really appreciate it. Without getting any delay, let's jump right in. Today we are going to discuss about operators and operands in Python. So before I start, I would like to mention one thing. If you are new to my channel or if you are new to this Python course, then I would like to recommend you to check out the earlier sessions before this video first and then circle back here because those videos help you understand the things better and before jumping into the new concepts. So first watch those sessions and then circle back here for a deeper dive. Now let's see the main topic about operators. So we have operators in Python. So an operator in Python is simply a symbol or is just a kind of a keyword that is mainly used to perform operation on a variable or a simple value. So here if you can see this example, here we have 2 plus 3. So the plus symbol which is there in between 2 and 3 values, that sign we can call as operator. And the use of this operator is to perform the operation between these values or variables, or we can call in Python as operands. So operator is the one that performs operation on these values, whereas operand is the one on which operation is going to perform. Okay. So we have 7 types of operators mainly in Python. So those operators includes assignment operators, arithmetic operators, relational, or we can call as comparison operators, logical operators, bitwise operators, membership operators, and finally we have identity operators. Now let's see each one of the operator in detail. The first operator is about assignment operators. So in the name itself, it's saying this operator is mainly useful for assigning the values that are generated after evaluation of right-hand operand to the left-hand operand. So in these assignment operators, we have 2 types, simple assignment operators and compound, or we can call as shorthand assignment operators. In simple assignment operators, assignment is mainly done with the help of equal sign. So here if you can see this example, we have a variable name which is assigned to a value Priya. So in other words, name is the left-hand operand, whereas Riya, the value is a right-hand operand. So here the value, which is a right-hand operand, is assigned to the left-hand operand name. So like this, assignment is mainly done with the help of equal sign in case of simple assignment operators. Whereas when it comes to compound or shorthand assignment operators, assignment is done with the help of equal sign only, but here some repetition need to be avoided. So here, if you can see this example, I have declared the value of x as a 2. And in the next statement, I want to add some value 1 to the variable x. So I have written the statement as x is equals to x plus 1. If you can clearly see this statement here, the left-hand side variable is repeated on the right side also. So 2 times it is repeated on left hand side as well as right hand side. So in order to avoid the repetition of the left side variable on the right side. So this statement we can write as x plus is equals to 1. So here we have a plus is equals to right. So this operator we can call as a shorthand assignment operator. So whenever this is a shorthand notation, so this statement can be simplified as like this. So this operator we can call as shorthand operator. So like this, the statements can be simplified by avoiding the repetition of variable on both sides. Now let's see the next operator. So before we go to the next operator, let's see the list of compound assignment operators that we have. So here I have given one table where I have given operator and its use along with the examples for each and every operator. The first operator, which is plus is equals to. So this compound operator use is to mainly This operator mainly adds the right operand to the left operand and assigns the result to the left operand finally. So here if you can see that here in this example, I have declared initially the value of a is 4 and then I have used the compound assignment operator which is plus is equals to. What this statement means a is equals to a plus 2, right? So I have the value of a as 4 and I was trying to add the value of 2 to it. So the final output will be 6. So I'm printing the addition of a, so that outputs the value of 6. So likewise, we have minus is equals to operator. So instead of doing addition, so this subtracts the right operand from the left operand and finally assigns the result to the left operand. So here in this example, we can have a minus is equals to 2. That means a is equals to a minus 2. So here from the output, we have the value of a as a 6. So 6 minus 2, 4. So the output will be 4. So this operator is performs subtraction. This operator is mainly responsible for performing addition. Similarly, multiplication. So this multiplies the left with right operand and then assigns the result finally to the left operand. So here you can see a into is equals to 2. So that multiplies a, that itself means a is equals to a into 2. So a value is 4, 4 into 2, the output will be 8. And we have division compound assignment operator. So this usually divides the left with the right operand and assigns the result to the left operand. So here in this example, you can see a slash is equals to 2 means a is equals to a by 2. So we have the value of a as 8, 8 by 2, that gives the 4.0. So this comes under regular division and in the result, it always gives the float value. So this is the modulus compound assignment operator. So it takes the modulus using two operands and assigns the result to the left. So in the result, it will finally gives us the remainder. So here this symbol. So here you can see performed a percentage is equals to 2. So that outputs me as a zero value depending upon the value of a in the previous step. Similarly, we have this operator, this compound assignment operator that mainly responsible for floor division on operands. And finally, remains same. The result can be assigned to the left. So this component assignment operator is for regular division. This component assignment operator is for floor division. So here a double slash is equals to 2. That itself means a is equals to a double slash 2. So this performs the floor division. So here in from the previous output, the value of a as floor 4 by means like 2. So here this floor division returns the result as a float value and one of the either of the operand values or float, or else if both operands are integers, then it results in integer value in the output. So here one of the operand is a have is a. So a value is 4.0. So that's why it results in float value. And we have finally this compound assignment operator asterisk is equals to. So this is mainly responsible for performing exponential or power calculations on operands that we have in mathematics, right? So to perform the power operations, for example, 2 cube, 3 cube. So those operations can be performed using this operator. So here a star star is equals to 2. So that itself means a is equals to a star star is equals to 2. And this outputs the 4.0. So here we have the value of a is 2 to the power of 2 means 4 value. So this is all about the list of compound assignment operators and its use and how we can use the form of code. Now let's see the next assignment operator about arithmetic operators. Arithmetic operators in Python are mainly used to perform arithmetic operations that includes all mathematical operations such as addition, subtraction, multiplication, division, etc. So what are the mathematical operations we have? So all those arithmetic operations can be performed using these arithmetic operators in Python. So here also I have given one table that lists all the arithmetic operators and its use and how we can make use of those operators in the form of code. The first operator is a plus operator. So the plus operator usually adds two operands. So here I have declared in this example n1 is equals to 5 and n2 is equals to 2. So in the result variable, I'm going to store the n1 plus n2. So this plus operator is going to perform addition between these two variables. So 5 plus 2, 7. So in the result, it will give 7. So next we have minus arithmetic operator that performs the subtraction from right operand from the left operand. So here n1 minus n2. So it performs the subtraction and results in 3 value. So here we have multiplication arithmetic operator that multiplies both left and right hand operands. And 1 into n2 results in 10 value. And we have a regular division operator that divides the left operand by right operand and returns the result always in float value. So n1 slash n2 or n1 by n2 results in 2.5. So here n1 is an integer, n2 is also an integer. So that results in 2.5, right? So whatever the division is going to make, it always results in float value. So 5 divided by 2 usually gives 2.5. And the next one is a percentage or modulus operator we can call. So it returns the remainder of the division of left hand operand by right hand operand. So that is n1 percentage or modulus n2 results in output value 1. 5 divided by 2 results in the remainder of 1, right? So it gives the remainder as 1 finally. And we have this floor division operator we can call. And this operator divides the left hand operand by right hand operand and returns the result in a whole number, which can be that is adjusted to left in the number line. So this floor division operator is mainly useful, like returns the integer value when both the operands are integers, or otherwise it returns a float value when either one of the operand is float value. So here we have n1 slash n2 results in the output 2. So here we have both the n1 and n2 are integer values. So the result is also here. Result is also 2, which is an integer value but not a float value. Suppose if we have one of the variable as a float value. So let's say suppose n1 is equals to 3.5, n2 is equal to 2.5 means it results in the output which is a float value. And we have a asterisk operator that returns the value of left raised to the power of right. So simply is a power operation. It performs the power operation. So here we have 5 square n1 star n2. So that results in 5 to the power of 2. So that gives the value as output 25. So these are the list of arithmetic operators and its use in the form of code. Let's move on to the next one. Relational, or we can call as comparison operators. So from the name itself, we can understand these are operators. These operators is mainly useful to do the comparison. So this is used to compare the values on left hand side operand with the right hand side and find the relationship between them. This is mainly useful for just comparison. And then we can see in this table. So here in this table, it gives the list of relational operators and the name of those operators and its use and how we can use in the form of code. So here first one is we have a less than symbol. So this operator we can call as less than operator. So this operator mainly returns true in the result if the left operand is less than the right operand. So here in this example, we have two values, x is equals to 2, y is equals to 5. And here I have given some conditions. The first condition I was checking with the help of using this less than operator. If x less than y, then I'm going to print x is less than y. So here we have x is equals to 2, y is equals to 5. 2 less than 5. So which is satisfied. So then in the output, it is going to print x is less than y. So like this, we can check the condition. These operators are mainly useful for comparison and mainly useful in the conditions while checking the conditions. Similarly, we have greater than operator to check whether right operand is less than the left operand. And then we have so here we have given x greater than or equal greater than y. If this condition satisfies means then it will print x is greater than y. Similarly, we have equal to operator to check whether both values are equal or not. Both operand values are equal or not. And we have not equal to operator. Similar to equal operator, it is opposite to the equal operator, not equal to. It only returns true whenever both values are not equal. So x not equals to y. If this condition satisfies, it will print the x not equals to y. Similarly, we have greater than or equal to symbol to check whether left operand is greater than or equal to right operand. If yes, then finally it returns true. If no, then it moves to the next statement. Similarly, we have less than operator, less than or equals to operator. This only returns true if the right operand is less than or equals to right or left operand. Sorry, here we have I have given some mistake. So instead of right, we have left. It compares whether right operand is less than or equals to left operand. So here we have these many different conditions based on these comparison operators. So like this, we can make use of these comparison operators in the form of code. Next one, we have logical operators. So logical operators in Python are mainly used to combine two or more conditions in order to perform the logical operations using logical and logical or and logical not. Suppose if we want to check two or more conditions in Python, then we can make use of these logical operators. These logical operators are useful to check two or more conditions at a time. And we have logical operators in Python. So these operators are mainly useful to combine the two or more conditions. And we have logical operators in Python. So these operators are mainly used to combine two or more conditions in order to perform the logical operations using the operators logical and, logical or, and finally logical not. So here I have given one table listing the types of logical operators. So we have three types of logical operators and, or, not. And for this operator, the logical name for these operators, these are the names we can call. So for and we can call as logical and, for or operator we can call as logical or, and not operator we can call as logical not. Suppose this operator is mainly useful whenever we are going to check two or more conditions. Suppose we have two conditions. So and if you are making use of this and operator means, then whenever those two conditions are satisfied, then only this AND operator returns true in the result. Otherwise, it returns false if one of the condition fails. So here, if you can see in the example, we have A is equals to 2, B is equals to 3. And here I'm checking one condition. In A, I have assigned, I'm checking two conditions, 4 greater than 3, and I'm making use of this AND operator in between these two conditions. 4 greater than 3 is one of the condition and 3 less than 4 is one of the condition. And in between these conditions, and I am making use of this logical operator. So this logical operator, what it will do? It will first check this condition whether 4 greater than 3. 4 greater than 3. So this condition is satisfied and then it goes to this condition 3 less than 4. So 3 less than 4 also satisfied. So both the conditions are giving true. So this AND logical operator also gives true in the result A finally. Similarly, OR operator is the opposite of AND operator. So this OR operator returns true if either of the operand or either of the condition returns true. So here we have the example A is equals to 4 greater than 3 or 5 less than 4. So in these three conditions, if either of the condition becomes true means this OR operator returns true in the result. Or else if both the conditions are also true means it returns true in the result. So here 4 greater than 3, his condition is satisfied, and 5 less than 4, the condition is not satisfied. So one of the condition only satisfied, so it's going to give true in the result. And we have not operator. So this is the operator. This operator mainly returns true if the operand is false and returns false if the operand is true. Let's say suppose if I initially declare the a value as a true means and I'm doing the not a. Initially I have the value of a is true, but I am giving not in front of a. Then it flips the value, like true value becomes false value. So in the output, it's going to give false. Similarly, if the first if I'm declaring the value of a is false means, then here if I'm giving a is equals to not a means, it flips the value of false to true, and it's give me the false value in the result. So this is all about logical operators in Python. Next, we have bitwise operators. So logical operators are mainly used to perform logical operations whenever we have two or more conditions, right? So similarly, bitwise operators works on bits instead of conditions and performs bit by bit operation. So here I have given one table that gives the list of bitwise operators. We have 6 types of bitwise operators and the name and their names and its use. And I have given one example demonstrating those operators. So we have this operator and operator, which we can officially call as binary AND operator. So this operator mainly copies a bit to the result if the bit 1 exists in both operands. So here if you can see this example, I have declared 2 variables, a is equals to 5 and b is equals to 3. So in binary format, how we can write this a value? In binary format, we can write the value of a as like this, right? 0, 1, 0, 1. So in other words, I can say 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So to give the value of 5, this is the binary representation. Similarly, the value of 3 can be represented in binary as like this. So the binary operand only copies a bit to the result if the bit 1 exists in both the operands. So here if I do the binary in the operation of these two variables means here the bit 1 is present in both the operands. So in the result, in the last digits place, the value will be 1. So here if I compare the digits 0 and 1, so one bit 1 is present in only one operand, so the result will be 0. Here also the result will be 0. Here also the result will be 0. So if I do the AND operation between this A and B, the binary result will be 0, 0, 0, 1. That itself means the output is 1, which is 2 to the power of 0, because one bit is present at the 2 to the power of 0 place. So 2 to the power of 0 is 1. The output will be 1. So here OR operator behaves opposite to the binary AND. It copies a bit to the result if the bit 1 exists in either of the operands. If the bit 1 exists in one operand also, it copies that bit to the result. So here, then that is represented by this pipe symbol. A pipe, B. If we do the calculations, means binary calculations, then it results in 0, 1, 1, 1 in this binary format. So in decimal, we have the value as 7. Similarly, we have binary XOR. So this binary XOR operator copies a bit if the bit 1 is set in one of the operand, but not both. Like if the bit 1 is present in one of the operand, then in the result, it copies that bit. But if the bit 1 is present in both operands, then the result will be 0. So here, if I perform this binary XOR operation between A and B, then it results in 0, 1, 1, 0. The output is 0. So here, if you can see A and B, 1 is present in here, 1 is present in both the operands. So it results in 0. Here, if you can move to the next place, 0 and 1. Here 1 is present in only one place. So in the result, the value will be 1. So that results in finally, if you perform the calculation like in the same manner, the value given the value will be 0, 1, 0. And the output is 6. And next one is binary ones complement operator. So it's a unary operator and it flips the bits. So 0 bit is flipped by 1 and 1 bit is flipped by 0. So here if you can see, if I flip the value of A, so then it becomes 1 becomes 0, 0 becomes 1. So it results in the value of 1, 0, 1, 0. The output is -6 because in Python, this binary ones complement operation can be performed using two's complement. Yeah. Two's complement representation. So this -6 is in the form of two's complement representations. That means minus of n plus 1. So minus of a plus 1. So minus of 5 plus 1 will be 6. In two's complement, the representation of this will be -6. And we have one category that includes these two, binary left shift and binary right shift. So this binary left shift operator, what it will do means, in case of binary left shift, left operand value is moved to the left by the number of bits specified by the right operand. Similarly, left operand value is moved to the right by the number of bits specified by right operand in case of binary right shift. These are opposite to each other. So if I perform a binary left shift operation by bit 1, by operand 1, by specifying the number of bits as 1, then it results in this binary output, which is 10. Similarly, if I perform binary right shift operation between A by specifying the number of bits as 1, it shifts the left operand value to the right by 1 bit, and then it results in the value of 2. So whenever if you want to do some binary kind of operations, then we can make use of this binary bitwise operators. In the next one, we have membership operators. This membership operators is only to test for membership in sequence data types that includes strings, lists, and tuples. So if you want to perform some tests in sequence data types, then we can go for membership operators. So we have two types, in operator and not in operator. So in operator is mainly to evaluate the condition. If it finds a variable or a value in specified sequence, that may be a list, string, or tuples, or otherwise it returns false. So here, if you can see in this example, I have declared the value of a, and I have given the list data type or list. I have declared the list that includes the values of 1, 2, 3. So in this is a sequence of list. So in this sequence of list, I would like to check whether a is equal to 3 is present in the list. So I have given the condition using this in operator. If a in my list, if the value of a is in my list, then I'm printing a exists, or else it will print a not exists. So here, this in operator will check whether this a value is equals to 3 is present in this list or not. We have the value of 3 in the list, so it's going to print a exists. Similarly, in not in operator is the opposite of in operator. It only evaluates the true if it doesn't find a value in that specified sequence. Otherwise, it returns false. So this not in operator I have used in this else if condition. If a is equals to 3 is not present in the list, then only I'm going to print the a not exists. So here we can check like this: if else if a not in my list. Since if a is equals to 3 is not present means, then it prints this message. So these are the uses of this in and not in operators. In case of membership operators, these are mainly useful to check for a value in the list of values or elements. Next one, we have identity operator. So this from the name itself, we can define. So this operator checks for identity of the values. It compares the memory locations of two objects with the help of IDs assigned to those variables. So in this identity operator category, we have two operators: is operator, not operator, is not operator. So this is operator evaluates to true. The variables on other side of the operator point to the same object, otherwise false. If the both values or identities of the both values are same or point to the same location, then it returns true, otherwise false. Similarly, is not is opposite to the is. If the identity of those two variables on other side of the operator point to the same object, it evaluates to false, otherwise it evaluates to true. So if A is B, if the identity or ID of A is equals to ID of B, then it prints A and B have same identity. Or else if ID of A is not same as B, then it prints the A and B do not have same identity. If the condition is true, then it prints this message, or else it prints this message. This is mainly used to compare the IDs of two objects in Python. So these are all about operators in Python. So we have seen types of operators. We have discussed in detail about each one of the operator, and we have seen their uses and their examples, how we can make use of those operators in the form of code. So that's all for today. I hope you like this session. If you have any doubts, feel free to post them in the comment section. We'll definitely answer your questions, and I will see you in the next video. Until then, take care, goodbye, and enjoy programming.